a little bit on our speakers. Vernon Vaughn is a veteran software craftsman with more than 25 years of experience in software design and development and architecture. He's been an author of several books, which I'll let him talk about in just a second. And then also joining us is Wes Williams, who is a hands-on software developer, architect, and designer for creating enterprise-class information technology systems. He's been working for Pivotal Software for quite a few years, working with our customers, helping them get the most out of their enterprise applications, particularly related to Gemfire and Apache Geode. With that, Vaughn, if you'd like to introduce a little bit more about the kind of consulting work that you do and a little bit more about your most recent books would be a great way to start.
Sure. So I consult around domain-driven design and architecture, and commonly I work with Fortune 500 companies and well-funded startups. So sort of a whole gamut. This past summer, I've worked with Fortune 500, Fortune 100, and Fortune 10. So a lot of clients are really interested in domain-driven design, and my books are what is called the Red Book among the DDD community. The Red Book is entitled Implementing Domain-Driven Design, and that book has been out, I think, about 3.5 years, or going on 4 years, and it's a bestseller. I've also written a book on reactive programming. It's entitled Reactive Messaging Patterns with the Actor Model. So it focuses more on using actors in the actor model, but is a very reactive-centric book. And my third book is Domain-Driven Design Distilled, which gives folks a really condensed look at DDD and sort of moves them through it quickly. It's the kind of book that even non-technical project stakeholders can absorb and get a common vocabulary for implementing domain-driven design in their projects. So, and I teach a 3-day IDDD workshop. So basically taking the subject of domain-driven design and taking a deep dive into it, showing teams, individuals how to implement DDD on their projects. And so all that keeps me pretty busy.
Let me start with just kind of one question. At the very beginning of last week's webinar, you kind of basically started out saying, hey, database guys, don't design your application around the database. And here we are talking to a community of in-memory data grid developers and users. So how do you bridge domain-driven design rather than in-memory data grid-driven design, which I could imagine some of our experts may find themselves doing once in a while?
Well, to some extent, it's probably a matter of perspective, but here's how I see it. If you attended the webinar last week where I presented about some of the tactical modeling tools with domain-driven design, one of those tools is called aggregate. Basically, an aggregate is an entity with a unique identity that can hold, a smallish cluster of other objects, and I see that aggregate being stored in a very natural way in Geode. So, think of Geode as, I guess, what Martin Fowler called an aggregate store. It does well at storing aggregates. And the other angle on that sort of fits with reactive is when you have aggregates or entities stored in your data grid, essentially you can send messages to those aggregates, and with Geode, I guess you call that a function. So you send a request from the client to the grid saying, I want this function to be performed, and here are some parameters to that function. The grid then looks up the target aggregate and basically hands over the operation to a function that takes the parameters and then applies that to the aggregate in the grid. And so that, you know, you can imagine building your ubiquitous language, your DDD ubiquitous language, around essentially the messages that you send to the grid and the operations on the aggregate. So I think it fits well.
So, I mean, fundamentally, is that partly because an in-memory data grid has an object-oriented interface?
Yeah, I mean, that's part of it, but you know, the aggregates themselves make the part of the ubiquitous language, and so you can actually model the business very naturally, and it's, you know, in essence, it's a lot less painful to use a data grid than it is to use OR mapping and a relational database. So you get a lot of payoff for using Geode.
And Wes, I'm wondering, as somebody who implements a lot of solutions, what's your thought on this topic?
I have a lot of thoughts on this topic, but one.
All right.
One is, like, for example, what Vaughn was just saying. For example, if you had an order object, and the order has order items, the data-centric way of thinking about that is you'd have an orders table and an order item table. But your business operation to give me the total of all my order items. Typically, they put that in some kind of service, so that gets the order, then gets the order items, and you iterate over all these order items. Your business logic, though, is in the service as opposed to in the what Vaughn's calling an aggregate or the order. In Geode, we can do that more naturally from a domain-driven design perspective, where as an object store, you can have the order object just have a list of order items, and the business logic itself goes on the order, not the function, not the application service. That just gets the order items and totals it up. So what does that buy you? What that buys you over time is really easy to maintain system, because your business logic isn't spread out all over the million lines of code. It's very nicely contained right where it should be on the order. So by Geode getting that order or that aggregate, and then you have a new order item coming in, as Vaughn was saying, it's a more natural way of developing and easier to maintain as you go forward.
Very good. Wes, did you want to pose one of your questions to Vaughn?
Yeah, I did. At the Geode Summit, we had a number of presentations on CQRS, and Eitan Suez, one of our Geode community trainers, presented a presentation here on CQRS, but it lacked a level of detail, Vaughn, that you had in your book. But I still get questions. What is CQRS, and why? When do we want to use it specifically, as opposed to other kinds of patterns? So, and then does it have to be transactional? Those are three different questions on CQRS that I get occasionally. Thought I'd give you an opportunity to field that.
Sure. Let me take a step back from CQRS and talk about programming sort of philosophy. I guess you could call it a pattern. although I don't know that its creator really called it a pattern, but this comes from Bertrand Meyer, the guy who created the Eiffel programming language. And Bertrand Meyer specified that interfaces, software interfaces, should follow what's called a CQS approach, which stands for command query separation. And probably you've heard of that, but essentially what the definition is, you design an interface to have two kinds of methods. It's either a command method or it's a query method. And if it's a command method, the command changes the state of the system. It modifies the state of the system in some way, but the command does not return a value in any way. If the method is a query on the interface, then the method returns a value based on the query that you're executing, but the query is not allowed to change the state of the system. So if, for example, you wanted to post an item to a discussion, maybe a comment to a discussion, the interface that you would use in CQRS would have a post method that would return void. And let's say that post takes a string comment, and so the comment alters the state of the system. If you want to know what the result of that post did to the system, you have to ask a query and ask, what does this discussion look like now? Or, you know, what happened with that discussion? And what you would get back from that is, say, a discussion with a number of post comments aggregated on it. So that's sort of the way to start thinking about CQRS. Now, take that interface that I just discussed. It's an interface that has, in this case, two methods. One is a command named post, and one is a query named getDiscussion, query discussion. If we wanted to turn this into a CQRS system, we would just take that interface and split it in half. We would create a command interface that only has command methods on it, and we would create a query interface that only has queries on it. And that is basically, in a nutshell, what CQRS is. Now, there are details around how you actually implement that, and essentially what you tend to do is behind that command interface, where commands alter the state of the system, you have a backing model, even a data store, that only stores the state of the system as the commands operate on it. And in addition to that, you also have a store that's behind the query interface, and that store behind the query interface is optimized for querying discussions and the post to discussions. So now think of using the command interface to post. You're going to alter down to the data store of the command model, and then somehow you need to have an impact on what happened with that command now needs to have an impact on the query store so that you can project the results of the command into the query store, and then the software can use the query-based interface to query the state of the query store, and that's basically CQRS in a nutshell.
Thanks. I'd just like to say I didn't prime Vaughn with the question ahead of time. that all came off the top of his head. But and so implementing that practically in Geode, we might have an order command region and an order query region. The order query region is highly optimized for read only, and the order command is with the aggregate.
So Wes, since
two are tied together with a transactional event.
And Wes, have you actually seen customers implement this way?
Yeah, Brian Dunlap at Southwest Airlines implements it that way, for sure. And there are other enterprises that do this pattern. It's a common pattern, but I know Brian does. We invited Brian today, but he couldn't make it.
And actually, Brian did go in depth about how he's using the Geode technology at Southwest Airlines a couple of months ago. So invite everyone to dredge up that recording should you want to.
So CQRS might really be advantageous if you have a lot of writers and a lot of readers, right? Or if you need instantaneous read response while you have a bunch of writers.
And those would be some of your domain requirements that might dictate the need for something like an in-memory data grid anyways.
Yeah, and it allows you to scale both sides independently, right? So you can right size the command side of things, and you can right size the query side.
There it is. That's the motivation. Perfect. Thanks, Vaughn.
Okay, Nikhil asks, two bounded contexts need to share a common event that they both understand. This introduces jar file dependencies. If it changes, I need to restart my server to pick up the new class dependency. Is there a way to avoid dependency restart? So I guess this is sort of getting into the implementation details of, say, Java language versus your domain-driven design.
Yeah, this is a really excellent question. In fact, it overlaps with what I've been discussing with the teams here that I'm working with. And what I recommend is that you actually don't distribute jar files that have your event classes in them. What I recommend is serialize your objects in a way that they can be deserialized with a standard technology. And essentially, when you deserialize, you reach into the deserialized object and ask for key value pairs, and the keys are the names of the fields in the event, or the name of the event itself, for example, so that you know what you're actually looking at. And when you ask for each of the fields by key, then you get the values, and you can make that a type-safe approach. So essentially, if you use that approach, you have to serialize your objects with field names, right? So you might think in terms of serializing as JSON. If you don't like serializing in that way, then there are other serialization approaches that you can use, but I really like to stay away from serialization that requires you to have a class to deserialize into. The definition of the schema that introduces your domain events to other interested parties and other bounded contexts, this is called a published language in domain-driven design. So you'll have a well-documented published language of this is the interface that you use to integrate with my bounded context, and that would have your domain event descriptions in them so that you can deserialize those.
And Nicola asks, is Avro a good way to help here?
Yeah, so that's one of the things I was going to mention is you could use Avro, but I think Avro does require you to have classes to deserialize in, because Avro, you at least need the schema, right? So you could, I believe you could build a deserializer to deserialize if you have a copy of the schema, and you can, I think Avro sort of advice says cache the schema on your side so you're not constantly asking the schema repository for the schema all the time. Does that make sense?
I think it makes a lot of sense.
So Swapnil says use Geode's PDX.
Yeah, sure. So, well, if the problem we're trying to solve is not having domain objects on the class path, when you're deserializing and serializing objects, essentially, and assuming your application is using Geode indeed, you can definitely use Geode's PDX serialization. And what happens at that point is your application only deals with PDX instances, and you don't really need to have domain classes on the class path. So each of the field you can then selectively deserialize using just the field name. So that also gets rid of the overhead associated with deserializing the entire object if you only care about only specific fields.
And Swap, can you actually just kind of explain to maybe the newbies that might be listening what PDX is? Because it sounds like an airport to me.
Sure. Sure. So PDX stands for Portable Data Exchange. And I guess just to reiterate, it allows you to basically serialize your objects and in such a way that your domain classes don't have to be present on the server's class path.
So this would be one way to deal with the dependencies that that Nikhil was referring to.
Yeah, and to Vaughn's point, it's also knowing about PDX, you can query like the keys and values that Vaughn was discussing on the PDX object without serializing it first.
Indeed.
Oh, very good.
Vaughn, can you just sort of give a quick definition of what we mean by reactive programming to people who might be new to this, and how does this fit into things like domain-driven design?
Yeah, and let me give a reference to the Reactive Manifesto. So if you go to reactivemanifesto.org, you'll see an effort from a pretty, I would say, relatively broad range of implementation organizations and people who have implemented a reactive style of library or framework or whatever. And so what that manifesto discusses is three, I guess you call them characteristics of a reactive application. And that would be that a reactive application is responsive. So even in the face of great scale and demand, your application can still be responsive. It's elastic in that it can expand and contract as the demand for your application increases or decreases, respectively. It's also resilient, so reactive applications can stay running and be at least partially available to consumers even in the face of failure, because they know how to prevent catastrophic failure. And what really backs all three of those characteristics is being message driven. So a reactive application is first and foremost message driven, and it's the decoupling of sender to receiver in both space and time that allows for these other characteristics to be met. And the reason for that is reactive tends to be largely, if not exclusively, non-blocking. So you don't ever block and wait on something. You can go inactive. You can be sort of, in a sense, in stasis for a time frame, and you will be dinged whenever it's time for you to react to something through a message. So hopefully that gives you, a simple overview of reactive, and then the manifesto goes into a lot more detail.
I think that makes a little bit of sense. Kind of just some practical questions. Does reactive programming tend to dictate a certain language over others?
I don't think so. I mean, I don't know if there's reactive COBOL, but there might be.
Is there anybody left in the world who could make reactive COBOL?
Yeah, maybe. So no, but people are using reactive with Java, with Scala, with C#, with Python, other languages too.
And so now, one area I keep hearing a whole lot of relation to reactive is Kafka. And it seems to me that Kafka is having a significant impact on sort of enterprise architecture and bringing reactive to this. Is that something you're seeing?
Yes, I am. We're using Kafka in the large project that I'm working on right now. And although I have to say, really, if you're using Kafka, I think first and foremost, you have to look at Kafka as, a queue or a pub sub exchange, and you can look at it as a high performance message bus. And I don't say bus in the sense of enterprise service bus. I just mean busing messages to whoever wants to know about them. So, and it is very high performance. So it's keeping people excited.
Well, and I mean, Kafka and these kinds of structures are essentially replacing the message queue in the enterprise architecture. Would you agree? What else is it converging?
Well, I mean, there are still companies using RabbitMQ, so I don't see that necessarily going away, but I think that Kafka has kind of captured some of the attention away from Rabbit.
And
is that what you meant? Maybe?
Well, that and yeah. And Wes, what's kind of, I know you've got a big interest in reactive. Maybe you can feel free to take a remark or even add a question to Vaughn.
Well, just some of my own experience with Geode and Gemfire is that customers need to load data into Gemfire or stream data out of. It's never just Geode in isolation. It's there's streaming data in or streaming data out or both. And so one of my interests are customers will often say, I don't care about speed, but in the end, they always do. So what is the fastest possible way to load data into Geode? The fastest possible way in such that if a transaction fails or if an item fails, I can automatically replay that some business rule number of times. So there was my interest in Reactor and Kafka to that combination to do that, and I'm getting phenomenal speed. Well, in the demo last week, just on my Mac, one Kafka broker, I was doing a million transactions per second loading into Gemfire in such a way that I could replay those items. And so that speed really garnered my attention. I'm still not done. I'm not sure I need Kafka because of the messaging capabilities of Gemfire itself. But that's where I'm pressing toward.
Well, so to me, the enterprise architecture trends, though, the messaging capabilities of Geode, for example, might be application specific, whereas Kafka might be a more generalized structure in the enterprise information architecture. Is that a
Yeah, oh yeah, it definitely has a place. It may even have a place within Gemfire itself.
Yeah. So if you're implementing multiple or many microservices or DDD bound context, each of those could be implemented using a different software platform, and Kafka allows you to exchange data between each of those platforms in a technology independent way.
That might be something for our product team to think about. I know Barry, I see Swapnil, I see William, that, we have some pretty fast proprietary mechanisms to exchange data, but that might be something for the community to consider.
It starts getting into the enterprise platform level of things as well. So, I mean, it's, we're in other communities, we're very fond of talking about data microservices, for example. So as I understand it, so your Kafka is essentially the bridge between these potentially, if you're building applications, and giving yourself an application independent layer.
Yeah, and what's nice about Kafka is it allows you to replay transactions. So if you lose a transaction a little later, you can go back and request that same transaction again. It's very, very quick. So that's one appealing feature of Kafka. If I lose a transaction downstream.
Well, that's another degree of fault tolerance in the system, which is nice. Wes, did we already exhaust the reactive topic for you?
Well, to me, it's a work in progress, well beyond this discussion. But I'm still having my thinking that, and I'm open to community involvement here. What is given if I have a billion messages I need to load into Geode, what is the fastest way I can load that, such that if a message doesn't meet a business rule and gets rejected, I can keep track of that. Given the number of processors and cores that I have on my machine, I'm looking for that fastest pattern that I can do that. And I think I'm narrowing in on reactive Kafka, and or reactive doing parallel streams.
Swap, you just made a really interesting conversation or point in the chat that I think deserves to be mentioned in.
Sure. So, well, to me, being reactive, means not only ability to do fast ingest, but also the ability to react to back pressure. So, if you're ingesting too fast and Geode cannot keep up, then to be able to say to the source, saying, hey, I have too much on my plate, please back off a little bit. And the way that is done, I guess, right now is through this reactive streams API. And so I think the people behind the reactive manifesto also came up with this proposal. So this is essentially a protocol that all reactive systems talk to each other with in order to do exactly this, right? Apply back pressure and things of that sort. So if we do implement reactive streams in Geode, then we will truly be able to interop with all the other reactive implementations out there.
And this is why I wanted to ask you, because there's a couple of implications to me in this. So right now I would assume that, say connecting Kafka to Geode sort of puts a reactive adapter into the in-memory data grid today. Is that a good way of sort of thinking about it? Because I know Kafka can queue a pool of messages if the receiver isn't able to process them all.
Oh,
Right.
the other, I'm sorry.
Yeah, go ahead. Go ahead.
I think another natural back pressure that's built into Kafka is you actually ask Kafka for as many messages as you can handle right now.
And that would be the protocols that Swap is talking about implementing in Geo. Would that be correct?
Oh, you're talking to me? I think so, yeah.
Yeah.
So basically you say, you know, if I can handle 100 messages per, you know, 3 milliseconds or something, then I ask for 100, and and that way I don't get 1,000 in 3 milliseconds.
And so essentially, Swap, what we'd be doing is adding that capability to provide that communication and feedback from the Geode system to the inputting system, such as Kafka, so that they can work together that much better.
Yep, absolutely.
Cool. I even understand this.
And with Vaughn's expertise on reactive implementations, he might be a good occasional consultant for which reactive implementation you'd be considering, Swapnil.
Sure.
And we definitely invite Vaughn to join the community discussion that occurs in the mail lists for this design as we think about this. Wes, I think what we need to do is provide a link to your Kafka demo from the last webinar. Yeah,
that'd be great. So essentially what it is the old NanoTrader project, Vaughn completely rewrote that in a pure domain-driven design format. Then what I did was I took the Spring Reactive Kafka project, their samples, and I plugged it in as a price feed to it and set up the observer pattern that Vaughn had set up in the demo with Gemfire regions that were eventing. And so I just connected the two and made a high-speed million transactions per second feed to this domain-driven design algorithmic trading system. So so there it is. Yeah, by all means.
And you're already rich now as a result, right, from running this?
Well, the market goes up, the market goes down, you know. All I can do is supply the algorithm.
Just as long as you're not the one who crashed it, right?
Yeah, I mean, let me see. While we're on this call, I've made $522,000.
Awesome.
So, yeah.
Wow. That's great.
All right.
Yeah. Go
Okay.
ahead.
So we're coming up to 10:50. I don't see any additional questions coming in. I think this was a really fun conversation. It's amazing how fast the time went past. So with that, I'm going to call this meeting to a close. Vaughn, we really appreciate you coming out to speak with us today, and look forward to hearing more from you in the Geode community in the near future.
All right.
All right.
Thank you for inviting me.